Hello guys, let's continue from where we stop on our former topic, random variable. Today we are going to look at what? Probability mass function. Probability mass function and probability density function. I said we're going to look at what? Probability mass function and probability density function. Let's start with probability mass function, PMF. Probability mass function. The probability mass function denoted as PMF is the function. The probability mass function denoted as PMF is the probability function is the function that assigns probability values to every element of a discrete random variable. Is defined as a function that assigns a probability value to every element of a discrete random variable. So when we have a discrete random variable, the function that assigns the probability value to every element of that random variable is called a probability mass function, and it is denoted as what? PMF, which is defined. It is denoted as PMF, which is defined as P of what? X. This is how we write probability mass functions. Let's look at the properties of what? Probability mass function. Properties of PMF. Number one, the number one property of PMF, we have that the probability of X must be greater than or equal to what? 1 for all X. So the probability of the PMF of X must be greater than or equal to what? 0, not 1. And number two, the summation for all X, P of X, must be equal to what? 1. When you sum over all the range of what? X, when you sum over the range of X, you have what? 1. And number 3, so number 2, we have what? Summation of what? Over the range of what? X, P of X is equal to what? 1. And when you have this, when you sum over the values of X and it gives you 1, we call it what? A proper PMF. We call it what? A proper PMF. But when you sum it and it is not equal to 1, that PMF, that probability mass function, is not a proper PMF. But when the value gives you 1, it is called a proper PMF. Let's look at the probability density function, PDF. the probability density function PDF, probability density function PDF. Given a continuous random variable, comma, a function that assigns a probability value to every element of this variable is called probability density function. So, given a continuous random variable, a function that assigns a probability value to every element of this random variable is called a probability density function, and it is defined as what? It is defined as f of what? X. It is defined as what? F of x, while the probability mass function is defined as what? P of what? X. Let's look at the properties of probability density function. Number one, f of x is greater than or equal to what? 0. Number two, integral over the range of what? Minus infinity to infinity of f of x dx is equal to what? 1. And when this happens, we call it what? A proper PDF. When the integral over the range of x of f of x dx gives you 1, we call it what? A proper PDF. Number 3, we have probability of a less than or equal to what? X less than or equal to b is defined as what? Integral over the range of a to what? B, f of x d what? X. This is the three properties of what? Probability density function. That the f of x must be greater than or equal to what? 0. It can never be 0. It can never be negative. Now, integral over the range of negative infinity to infinity of f of x dx is equal to 1. And when this is equal to 1, we call it what? A proper PDF. And the probability of a less than or equal to what? X less than or equal to p is equal to integral over the range of a to p f of x dx. Let's solve one example. Example 1. Given a continuous random variable x with PDF probability density function f of x equal to what? X over what? 2. For x greater than what? Or equal to 0, less than or equal to what? 2. Show that f of x is equal to what? Is a proper PDF. Given a continuous random variable x with PDF, f of x is equal to what? X over 2, where x is greater than or equal to 0, less than or equal to what? 2. They say we should show that f of x is a proper PDF. For you to show that f of x is a proper PDF, let's look at what? That property of what? A continuous that property of probability density function. Now number 2, which says that the integral over the range of negative infinity to what? Infinity of f of x must be equal to what? 1. So putting this in this is the density function. F of x is defined as what? X over what? F of x is defined as what? To be what? X over what? X over 2. Okay. So putting it in the integral, we have integral our x, the value of x here is what? X ranges from 0 to what? 2. So we have integral over the range of 0 to what? 2 of x over 2 the what? The x. So if we integrate this, we will have what? We will have do the normal integral. We have, first of all, we have bring 1 over 2 out from the integral because it is a constant. We have 1 over 2 integral of 0 to what? To 2 of x dx. And when you integrate x, you have what? 1 over 2 of x raised to power 1 plus 1 all over what? 1 plus 1. We pass the limit which have 0 and what? 2. So we have we will have 1 over 2 bracket x squared all over what? 2 pass the limit is 0 and what? This will give you this 2 multiplied by 2 will give you what? 4. You have x squared over what? 4 pass the limit have what? This. So this will give us if you put the value of what? X to be what? 2, you have 2 raised to power 2 which will give you minus 0 raised to power 2 all over what? 4, which will give you 4 over 4 minus 0, which will give you 1. So since the integral over the range of 0 to 2 of this probability mass function gives us 1, we call it what? A proper PDF. So let's take one example. Let's take one example on a probability mass function to show that it is a what? A proper PMF. Given the table, example 2, given the table below, we have x, this is our what? P of x, we have 0, 1, 2, that's when we have 1 over 4, 1 over 2, and we have what? 1 over what? 4. And they ask you to show that this is a proper PMF. which is probability mass function. So this is the random variable which ranges from what? 0 to what? To 2, and this is their corresponding probabilities. Now, for you to show that this is a proper PMF, remember our property number 2. We say that for this to be a proper PMF, that the summation over the range of what? X of P of X must be equal to what? 1. So what we do is just to sum these probability values. If it gives us 1, we conclude that it is a proper PMF. But if it does not give us 1, we don't call it what? A proper PDF. So summation of this over the range of what? Our X now ranges from what? 0 to what? To 2. To 2. X equal to what? 0 to what? To 2 of P of X, which is equal to 1 over what? 4 plus 1 over 2 plus 1 over 4, which will give you what? If add it, for you to add this is a fraction. So you find what? The LCM. The LCM is what? 4. So you write the 4 down. All over what? 4 divided by 4 will give you what? This is 1 plus what? 2 plus 1, which will give you 4 over 4, which gives you 1. So since it gives us 1, we call it what? A proper PMF. Thank you.